Hello all my JavaScript friends, this is TheVirtuoid, aka Mike Smith, and this is our final video in our racing game. Now I say final video, but it may not be. I've had a lot of fun in the last 3 weeks, really diving deep into how to construct these cars and getting the physics correct and everything, that on occasion I may release something as I kind of continue to dive deep into it, especially when dealing with the physics. Because as you can see, although as you will see, we got the cars ready to go, but there are a couple of things that still need to be taken a look at. So we're going to recap on this video of the things that we have accomplished and then take a look at some of the things that I would like to see accomplished in the future. So let's get at it. Before anything else, let's take a look at a sample run of 4 cars. There goes the beeping sound. And here we go, we're off. It works decently well. Ooh, that one almost fell off the track. They run more of an effect of just sliding down tracks than really rolling down the track right now. That's one of the issues we're going to have to take a look at here. Looks like all 3 of them got stuck on top of here. Nope, they're finally going. Come on, push, push, push. Go, 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 go. There we go. There we go. And we'll get the last 3 cars. Hey, will that other car pass? Oh, I thought the brown one might pass. Well, let's go ahead and F5 it again and take a look at it. It actually works fairly well. The low poly car number 2 there really seems to have some issues. But generally, it works pretty good. Every time we get into the curve, we really wreck. But we'll have to take a look at it and figure what's going on there. And I think a lot of it is with the friction. So we got that kind of issue. That's one of the issues that we still are working with, is the frictions really are pretty poorly done, to the fact that the cars just basically slide more than they roll. And of course what we really want is just a roll. I mean, we're taking a look at this guy up here. He shouldn't be sliding like that. He should just be stopping. But I think obviously I know the friction is incorrect on the track. Another thing I noticed is sometimes that the Camaro, which is right here, will sometimes flip over to the left. I think that's mostly a problem or an issue that I have with the how far off the track they are before I drop them onto the track. Let's get down here and see who can finish up the racing. So those are a couple of things I would love to be able to work on. Hey, that's the first time I think he's... Oh, if we don't have a full finish here? Nope, not a full finish. And that's one of the other issues that we have here. We don't have a full finish. He's actually going backwards. Go, dude, go! So, so the sounds that you hear in the background will continue on and on and on until forever, until I hit F5. It waits for all 4 cars to cross the finish line. So that's one of the other issues that we have with it here. So if we go along here, that's one of the things I would love to be able to fix up, is to get these cars running better, getting the friction done correctly, so that it will do the curve correctly and it won't just continually mess up like it does here on the curve, as you'll see here in just a second. Boom! Everybody just kind of crashes into each other and we ride along the wall. Looks like we're going to have all 4 finish this time. That's going to be nice. And we didn't get to see it because I messed up my camera, but that's the way it goes. So now let's take a look at the code. Here we are at the code. A couple of things I want to show you that we have here. Now, there is a lot of stuff that I worked on here. This is the car box section here. That's one of the first things that I want to be able to fix up here. The car box is code that allows me just to look at the individual cars themselves. As you can tell, I've got a couple of cars down here. I did a Dodge Charger, a Ferrari, a low poly 1, low poly 2, another poly car, and a Camaro. Some of these did not work very well out of the box, mostly because I'm still have some issues with getting the scaling done correctly, getting the rotations and things like that. But most everything came out of the cars, so that when I actually did render the cars, let me get that out of the way here. There we go. So when I actually did render the cars, what I did do was I just went ahead and just import them straight out and called it car 1, car 2, car 3, and car 4. And I put in there what the instance of it was once we loaded in from the database. So obviously what we want to do, one of the things here is we want to be able to load the cars in from the database, which means that the instance and the scaling would be part of the database itself. I don't have that right now, but that's the way it is. So one of the things that this section here does is that this allows me to be able to say I want to drop the cars down onto the starting location. This shouldn't be hard-coded here. This is hard-coded for a certain position of the starting block. For instance, cars that are a little further down on the list will get placed a little further, or further down on the starting gate will get placed further down, because we're assuming that we have a certain angle to our starting position, and this should not be that way. I should be able to bring in the starting direction vector and the starting position of the starting gate, and that will allow me to be able to get dropping of these cars absolutely perfect. Because as you remember from the video, in fact, we'll just do another one here real quick. You know, sometimes what will happen is that the Camaro will go sideways, which of course it's not doing now, of course, but sometimes the Camaro will go sideways and coming out of the gate, and it would just, you know, be pretty bad. But anyway, back to the code. So the starting position and the starting vector these positions right here, which are the position of the cars relative to the starting position, needs to also take into account the starting vector. And I kind of did that a little bit in the render section here, where I'm passing the starting vector. That if the starting vector z is equal to 0, then I actually switched around the z and the x values in the car parameters. As you can tell here, this is awful code, but I need to do it for the demo. That's why I've done it for the demo. What really needs to happen here is we need to take that starting vector and figure out the x, the y, and the z values of the position of each one of these cars in their 4 ordinal positions. That's what really needs to occur. That's one of the good things that we'll need to do a little bit later on. And so in that particular case, we just set the position, we build the car, and we render him, we push him. That's all, no big deal there. That's one of the things we want to take a look at. The other big thing is getting the friction done. As you can tell, when we raced through, the friction was just awful. I mean, the car could be sideways, upside down, it doesn't matter. It still flies on as if it was rolling on wheels. So what we need to do, and this is something I actually had started doing beforehand, before I did the demo here, and I thought, okay, this is getting very complicated, is that it's not just a matter of setting the friction on the wheels, but we need to set the friction on the tires, on the friction on the chassis, and so on and so forth, and things like that. That is what's going to be very important, is to figure out the relationship between the friction of the track and the friction of the wheels. So for instance, when I render a straight, I'm going to generate a straight road. This does all the generations of the straight road. I return the actual mesh itself, so that when I apply the physics, let's take a look at that code. That will be inside the layout renderer. So if I'm going to take a look at the render function of our layout renderer, and again, just for review's sake, the layout renderer is what's called within the application to physically render the layout onto the screen. But when we do this, we go through, are we a starting anchor? Are we a straight? Are we an ending anchor? And so on and so forth. In which case we go through the render function for each one of those. Then the idea here is that we do the physics aggregate, and we set up a particular friction. Now, what's the friction value set to? Well, let's go find out. The friction value is set to basically either 1 or 0.2. And this is something, basically the ending anchor, I want a full 1. At the closing one, I want a 0.2. This is one of the first things that are going to have to be played with as we play with the game, is to find out what the best friction is. Should I just set it all to 1? Should I set everything down to 0.5 maybe, or something like that? I don't know. That's just one of the things that's one of the things we'll need to start operating on. And the second thing is obviously, well, not the second thing, but the big thing is doing the cars themselves. Let's take a look at what some of the things that we had to do on the cars. Now, within the car box, which is where I did all of the experimentation with the cars, I had what I was called an old car design. And that basically allowed me to save everything off. And it ended up that one of the older car designs that I had saved off when I was working with this thing worked the best. So I just kept that going here. And so what I ended up with is, I have a Ferrari 2, 3, and 4 are worthless ones now. There's my low poly count one number 1 car, there's my low poly count number 2 car, there's my poly car, there's my Camaro, there's my Dodge Charger. So these are all the different cars that are associated with the game here. The Camaro and the Dodge Charger did not work very well at all, and so you didn't see those coming up on the screen. But basically the idea is that, let's take a look at the Ferrari. But basically the Ferrari is the base one that I've been using here. Basically the idea is that what I discovered is that we have a plethora of information that is copied from one to the other. For instance, I got the Ferrari here, and let's just pull up Polycar, for example. Both of these are pretty much exactly the same. If I was to scroll all the way up to the very top on both of these, and just flip between the two, there's pretty much not any difference whatsoever. The big differences that end up happening is if we scroll down, even further down, if we further down, the really giant difference that I've got on this is, first of all, this section right here. This is the wheel offset based upon the model, that once the chassis is built and the chassis is figured out, then the wheels are put on the chassis at a certain at the corners, and then it is offset based upon this particular offset, and the model, each of the different models changes this particular offset. So the idea here would be, to go a little further on this, is to build a base car, and then this will be one of the pieces of information you'll pass into it. A lot of this is card rotation. I was never able to figure out how to get the card rotated correctly. That's a big thing on there. Wheel material stays the same, wheel stays the same, build wheel stays the same, chassis stays the same, chassis physics stays the same, wheel physics stay the same. In fact, wheel physics here, we got the wheel friction here, we got the chassis friction, which is set at 0.5. That's hard-coded. It shouldn't be hard-coded. Again, those are also some of the things we're going to take a look at if we're going to do the friction. The wheel constraints are all the same. The chassis constraints are all the same. The build model obviously would be very different, but even within the build model, I found that there's a lot of similarities. We always loaded a model, and within Babylon, mesh number 0 is always the model root. Always. And all of the other meshes are children off of this particular model root. So that's one of the things I've discovered with all of these GLB files that I've been loading in. That's wonderful here. Now, from that particular point on, things do change. So let me go around line 407 in my Polycar and show you that particular difference there too. Oh, hey, that worked out great. So in the Ferrari, one of the things we did here is we got a bunch of meshes that represent the tires, and we wanted to get rid of those. Well, in the Polycar, I had to do the same thing. And what I ended up doing was I sat there and disabled all of the physics and disabled the collision box and disabled the tires and all that. It just had the model appearing up on the screen. And how did I do that, you ask? I can hear you saying that now. What I did is all I simply did is just go and decide here and just, and all I did was just go da-ba-da-ba-da-ba-da, boom, and suddenly no physics are applied whatsoever. Or if I want to go even further, I could have gone boom, and only the model would have shown up on the screen. So that's the quick and easy way to being able to disable the physics, or to disable the chassis and the wheels and all that. But what I did was that once I got that up on the screen, I went through each and every single mesh until I found out where the wheels are, because I wanted to basically find out the size of the wheels on the model, and I wanted to find out where the model itself, the wheels were on the model, and I wanted to be able to get rid of them. So that's one of the things I ended up doing here, going through all that. Ferrari, I did it manually without putting any kind of notes there. And I found that there are two different things that occurred here. On the Polycard, we had a mesh that represented basically the entire car, which was absolutely perfect. And by doing that, that allowed me to be able to figure out what the largest and smallest number in the for the model was, and allowed me to save those model dimensions. If that wasn't available, like it wasn't inside the Ferrari, I had to get it manually itself. Although I found out later that if the mesh number 9 in this particular case allowed me to be able to do that, so I would actually change this in that case. But I've kept this code in here to remind myself that, hey, sometimes you got to figure out manually. So to do that, you just have to go through every single one of the meshes and figure out what the minimum maximum was. and that allows me to get the low and high, which allows me to get the model dimensions. Then all I have to do is figure out what mesh represents a tire, get the minimum and maximum amount there, and do the same thing here. And so what I end up with in each one of the cars is a model dimension, which is a wheel height, a length, a width, and a height of the model of the wheel and the wheel height itself. And then past that point, there is nothing else except possibly, you know, well, actually, even that, there is actually nothing else to it. Everything else is exactly the same. And so that's the wonderful thing. The only thing that I found out even in the build model is I got to change where the model is. If there's any kind of scaling, Will may have changed that. I don't have any kind of scaling in this case. I need to figure out where the meshes are for the wheels so that I can make them disappear. I need to figure out how to determine the largest mesh in there, or where the bounding box for the meshes are, so I can build a collision box a little bit later, and I need to find the wheel height. Past that point, everything else is exactly the same. So it could end up being that the base car is all of this huge code. I mean, this sucker runs, you know, boom, 574 lines long. It could be that 500 lines long, and each car extends it and just has this one little piece here for, oh, I'm building the model here. Here's the model. Here's all the dimensions. You know, give me all the dimensions. Or, you know, here's all for the wheels. This is the offsets you need to do for the wheels. So that's one of the cool things about this. Obviously, I didn't do that. I started doing it here and kind of gave up on it because it was starting to run into some issues. And that's when I decided, you know, just for the demo here, let's just get it. Just do a cut, copy, paste, copy, paste, copy, paste, make the changes and go from there. So that's one of the things. So those are kind of the things I'm going to take a look at here, or try to take a look at maybe over the next couple of months. You know, I want to get those cars in a lot better shape than, you know, code-wise, in a lot better shape than they are now. Get the friction working, because I think that will really help out a great deal here as we run the races. Let's hit F5. I think this will really help out here. Oh, we can see where it switched over to the left. It finally did it. It kept doing that all the time before I did my demo here, and now it's finally done it. If we get the friction working, I think that will fix a lot of these issues that you have here where they just go flying all over the place. Clean up the track a little bit. You see we still have some joinery issues there, so we do need to kind of clean up the track. The finish line works great. Finish line looks at the collision box. The collision box all look great. They're not perfect. They're just a box. It would be really nice if we had them perfect, but we don't. So those are the kind of things that we're going to take a look at slowly but surely. And then maybe, I don't know, by May, June next year or something like that, maybe what we'll do is we'll build a more complicated track, and we'll put actually model houses, we'll put grass, we'll put a skybox and everything. We'll build a real racetrack, but that's going to be months down the road here, because I've got another project coming in right after this one, and right after the whole tower is all done, and I've got to get my website up and running too. So that's some of the things that we're going to be taking a look at. And I think that's pretty much going to cover it all. I really appreciate you sticking with me here on the racing car series. I'm a lot better shape than I was 2 years ago on that one. But I mean, as you can tell, we still got a lot more work that has to get done with it. But it's been a great deal of fun. Thank you again very, very much for sticking with me throughout the series here. Make sure you hit the like button, subscribe if you'd like the channel, which of course I'll be telling you about here in just a second. Thank you again very much for joining us. Keep on coding. Thanks for watching. Subscribe to this channel to view more videos. Click on the like button on this video and visit us at TheVirtuoid.com. Also, support us on Patreon, where you can get access to member-only videos. Links are down below. Again, thank you very much for watching, and keep on coding.